part 3, and then I think the notes are all done. The remainder theorem. The remainder theorem allows us to evaluate a polynomial at a certain value. Now, we could do old school and plug and chug, or we can use the remainder theorem. And I'm going to show you how. I like the remainder theorem, but just in case you're a little old school and you like plug and chug, we can definitely do that too. So let's say that we have a polynomial, x to the 5th minus 2x to the 3rd minus x squared plus 2. And I said, okay, what is the polynomial with the x value of 3? Well, the old school method would be, you would do 3 to the 5th power minus 2 times 3 to the 3rd power minus 3 to the 2nd power plus 2. And then you would probably, I would assume most of you would probably grab your calculator. Or maybe you're brave and you're going to do it in your head. That would be awesome. Maybe you just want to like verify it in the calculator. So let's see, be parenthesis 3 to the 5th, oopsie, to the 5th, minus 2 parenthesis 3 to the 3rd, pull minus parenthesis 3 to the 2nd, plus 2. Oh, I didn't do plus 2. That's okay. Plus 2. There we go. So the answer is 182. Now, if you're kind of a little more old school and you're like, yeah, I just like that way, that's fine. There's nothing wrong with that. Oakley dokley. But I personally like the remainder theorem. Let me show you how it works. So you do synthetic division, but you do not change the sign. Don't change the sign, okay? Because if like x is 3, then that would have been x minus 3, which proves you just leave it as a regular 3. So if I give you the x value, do not change the sign. Now, I do want you to notice we have a 0x to the 4th, x to the 3rd, and we have a 0x. Those are important. So my first column is an x to the 5th because that's what my problem starts with. So it would be 1x to the 5th plus 0. So it's x to the 5th if you need to label it. X to the 4th. You don't have to label it, but some students just like it. X to the 3rd is negative 2. That was the x to the 3rd problem. And then there's a negative 1 in front of x squared. There's a 0 in front of x, and the constant is 2. I like synthetic division. Maybe I'm weird, but I just like the synthetic division. So I drop down the 1, multiply with 3, add to 0. Now I take that 3, multiply to 3, add to negative 2. Now I take this 7, multiply it to 3, add to negative 1, multiply it with 3, add to 0, multiply it to 3, add it to 2. Now remember, I told you this was called the remainder theorem, right? That's because whatever you get as the remainder is your answer. Remember how over here we got 182? Now, maybe you're like, that's a lot more work, Mrs. Langeli. Well, I don't know. I might be able to do that faster than you plugging it in. So to me, it's totally worth it to use the remainder theorem because I can multiply and add a lot better than I can in my head take things to exponents and worry about my negatives and positives with parentheses and stuff. So we can say that the polynomial, when I plug in 3, gives me 182. I'll do that again. Again, you can do this the old plug and chug method. You would plug negative 4 in for the x's, but you would have to use parentheses. Please be careful if you're going to do the old school method. You have to do negative, You have to do negative 4 to the 5th power minus 3 times negative 4 in parentheses to the 4th power minus 28 times negative 4 to the 3rd power plus 5 times negative 4 plus 20, and you would get something. I'll do that. Now, if you just want to fast forward the video and not watch me struggle with my calculator, that's okay. I'm going to go ahead and do this. So negative 4 to the 5th minus 3 times negative 4 to the 4th minus 28 times negative 4 to the 3rd plus 5 times negative 4. Ooh, looks like I'm missing a squared. So that I have to remember that when I do my synthetic. Oh, look at that. I end up getting 0. That's weird. All right, so if you plug in -4, you get an answer of 0. Cool beans. Now what we're going to do is my favorite way, if you don't mind. I'm going to do the remainder theorem. Now, if you don't like the remainder theorem and the old plug and chug makes you happy, then hey, life's, there you go. Remember, I told you you do not change the sign if this is the type of problem, if you're trying to evaluate. So we can keep it as a -4. X to the 5th is a 1. X to the 4th is a -3. X to the 3rd is -28. X squared is 0. X is 5, and my constant is 20. Remember, we were missing an x squared term, but we can't miss that in synthetic. So there you go. There's one benefit of doing the old school method. So drop down the 1, multiply with -4, add. 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 So it's like, what in the world does this mean? Well, we were trying to do this like plug and chug thing, or like what do we get if we plug in -4? So the answer is not an equation. The answer is simply what you get for your remainder. So you can say, if I plug in -4, my answer will be 0. And I honestly don't even know which one was faster. I don't know if using the calculator was faster or if me doing the remainder theorem was faster, but either way, you get a final answer of 0. All of these are extra practice, and if you want I have a video of all of these. If you want it, please let me know.